Okay, so what we're talking about today is nonlinear systems, okay? And so we've done systems in the past, but we've always worked with systems that are linear. And so a nonlinear system is two or more functions, and they don't have to both be linear. One could be linear, one could be quadratic. There's a lot of different options. You can solve by graphing and finding the intersections. Or you can use elimination or substitution. If you choose to solve by graphing, it's much easier if you have a graphing calculator. These are the steps right here. You would plug it into y equals, and then you follow these steps. So I'm going to kind of follow these steps here by graphing in a calculator and by hand, and then we will do it by hand with substitution. So this is a plus 6. So I go up 6, and then my slope is up 1 over 1. I'm going to make the dots to make sure that I can get a straight line, because if it's not straight, it gets difficult. This one, my vertex is at -6, 0. So I found one intersection right here. I know that it crosses at -6, 0, but I'm not sure of the other one. And so with parabolas, you can make a table to find all your information, or you could go ahead and just plot it in the calculator. Turn these plots off. So I got x plus 6 and 1/2 x plus 6 squared. So I'm going to make sure my window's good. And that's the first line I had, and here's the second one. So if I follow my steps, I'm going to kind of just draw a rough U, because I know that's what it does. But I'm going to follow these steps here where it says second trace. You go to number 5, and I need to pick my intersection. I already have this one on the x-axis. I'm looking for this one right there. So I'm going to move my cursor towards there. And when I'm close to that, I'm going to hit enter. And I want it to stay there until I see the word intersection. And so the second intersection is at -4, 2. So the two answers for this graph are -6, 0 and -4, 2. Now, if you were going to do this by substitution, you know that y equals y. So you could pretty much cross these off and say that x plus 6 equals 1/2 of x plus 6 squared. So there's a couple ways you could do this. You could expand the x plus 6 and distribute the 1/2. But really, I don't like fractions, so I'm going to get rid of them. So I'm going to multiply by 2. And when I multiply by 2 over here, I have to actually distribute it. So I get 2x plus 12 is equal to, that is crossed off, x plus 6 squared. And x plus 6 squared, that's x squared plus 12x plus 36. And if you're not sure how I did that, you could FOIL that out or double distribute. And so now I need to get it to equal 0. So I'm going to move this 2x over here by subtracting it. And I'm going to move the 12 over here by subtracting it. And so I get 0 is equal to x squared plus 10x plus 24. Well, now I have something right here that you're able to factor, okay? And when you factor it, my factors of 24 that add to give me 10 are going to be 6 and 4. And so that's how I get a -6 and a -4. Those are my two x values. To find your two y values, you have to plug it in an equation. It doesn't matter which equation you use, they will both work. You can either plug it into this top equation or the bottom equation. And to me, the top equation is the easiest right here. So it'll be -6 plus 6. So that's where 0 comes from. Or I can do this one over here, -4 plus 6. And that gives me 2, and that's where the 2 came from. So you could totally graph these by hand by using substitution, or you can graph them in your calculator and use your intersection function. Okay, so let's look at number 2. I'm going to start off by graphing this one. -3 is a horizontal line right here. That one's nice and easy. And so now I'm going to graph this one, which I know I go to the left 2 and down 3. So to the left 1, 2, and down 3. And it goes up. And this one only crosses at one point right here. So this answer is -2, -3. If you did your substitution method here, again, I'm going to plug in a -3 here. I get -3 equals x plus 2 squared minus 3. If you add 3 to both sides, they're gone. So I get 0 equals x plus 2 squared. To get rid of a square, I'm going to square root. The square root of 0 is 0, so I get x plus 2 equals 0. So if I subtract 2, I get x is -2, which is what I got here. Well, I already knew y was -3, so there's the other answer. Okay. All right, so what we're going to do now is we're going to do 2 problems. I want you to try them either by substitution or graphing. So you're going to copy the 2 problems down, and you're either going to do substitution or graphing, and then you're going to come back and see to check your answer. Okay, so plugging this in, -x plus 3, 3x squared minus 4x plus 3. There's the first line. There's the quadratic, and it does touch twice. So I could do second trace number 5. Oops, that's 6. Second trace number 5. My intersection's on the first one, so I hit enter until I see it. And the first intersection is at 0, 3. Now I need to do the same thing again, second trace number 5. But this time I need to move my cursor, physically move it to the right to the other intersection. And I'm going to hit enter until I get that intersection. And that one's at 1, 2. So there's the 2 answers. To do this algebraically, again, you set these equal to each other. And so I add an x and subtract a 3, add an x and subtract a 3. And I get 0 is equal to 3x squared minus 3x. Well, for this one, it's not that bad of factoring because I could take out a 3 and an x. So I'm left with x and 1. So this one is x equals 0, and this one is x equals 1, -1. No, positive 1. To get rid of a -1, you add 1. So those are my 2 x values. Well, again, I'm just going to plug it into this nice equation here. So it'll be y equals 0 plus 3. So 0 is with 3, or y equals 1 plus -1, because there's a negative there, plus 3, which is 2. And so that's where that comes from. So again, you could graph them by hand or by the calculator, or you can use substitution. All right, let's look at the next one. X minus 4. Oops, the wrong button. Or x squared minus 4x. Okay, so we graph it. There's the line. There's the graph. It touches in 2 places. And so second trace number 5, I find the first intersection. And so that first intersection is 1, -3. Now I do the same thing by going to the other intersection. And so I have to move my cursor over to the right. I'm going to hit enter 3 times. And this one's 4, 0. So there's the 2 answers. And so now if I do this by hand, again, x minus 4 equals x squared minus 4x. I'm going to subtract an x, add a 4. So I get 0 equals negative 5x. Oops, I forgot the x squared. 0 equals x squared minus 5x plus 4. And now my factors of 4 that add to give me 5. Well, that's 4 and 1. And the only way I can get a negative 5 is if they're both negative. So this gives me an answer of x is 4. And this gives me an answer as x is 1. And so now I'm going to plug it into the equation. So y equals x minus 4. So it's 4 minus 4. So for 4, I get 0, which is what I get there. And over here, I'm just going to plug it in again. And instead of x, I'm going to plug 1. 1 minus 4 is negative 3. And so that's why 1 is paired with negative 3. So you could do these by hand using substitution, or you could do these by graphing if you have a graphing calculator. Now, one thing I do want you to notice is that sometimes you're going to get two graphs, and it might look like this, where you have a line and you have a parabola, and they never touch. Well, if things never touch, this is a no solution, okay? So if you ever get something that never touches or your x's are gone, it's a false statement, just know that that's a no solution.